So you've tuned in to Hyperbolas Part 2. Just a quick reminder of some things you need to be doing. You need to be taking notes. You need to have your book out. And let's see, you're going to need to ask a question and bring that to class tomorrow, as well as I'll give you a few instructions at the end about some other things I'm going to want you to do. I'm going to warn you right now, I'm probably going to be overkill on these two new concepts because they're really, really simple, but I just want to make sure that I've done my duty here to you and given you everything that you need. So we got two things to look at today. Number one is, well, last time we looked at a couple of ways to define a hyperbola, and now we're going to look at a couple of new ways to define a hyperbola. One is by its eccentricity, and we can do this for any conic section. We're going to use a scale, and wherever the number falls on the scale, that will tell us what kind of conic section we're looking at. And then secondly, we'll define a hyperbola or any conic section by a special value called the discriminant, which you may have heard of before, but we'll get to that when we get there. Let's talk about eccentricity first. In these that I've shown you before, eccentricity is this ratio over here. We'll define it in a different way, but I want you to notice that for a parabola, the eccentricity is always 1. No matter where I drag this point around, the ratio of PQ to PF to PQ is always 1. If I go to an ellipse, I can change that ratio, but that ratio is only going to go between 0 and 1, at which point it becomes something else. If it's a circle, it's going to have an eccentricity of 0. If it's an ellipse, it can go between 0 and 1. For our good old friend, the hyperbola, notice here that right at where the focus is set right here, we've got an eccentricity of 1.67. If I change the focus point and move it in, I decrease its eccentricity as it gets closer to the directrix. And I pull the focus away from the directrix, and my eccentricity can grow. And it can get really super big. But it's greater than 1. So what we have here with these things is defined as C over A. C over A. And that's when we're talking about the A squared and B squared equals C squared thing. So for circles, the eccentricity is 0. Because for a circle, A is the same thing as B, and they're both equal to 1. And you think about it, 1 squared minus 1 squared would equal 0. So C equals 0. 0 over 1 is 0. For ellipses, it's between 0 and 1. And here's the relationship for A, B, and C. For parabola, it's always 1. And for our friend, the hyperbola today, it's greater than 1. And here was the relationship between A, B, and C. So there you go. That's the rule. You might want to pause at this moment and write some of that stuff down, unless you wrote it down out of the book. But take a couple seconds, so pause it, take a moment, write that down, and then press play again, and then we'll keep going. Okay, so hyperbolas come in either this form or this form. Either x comes first or y comes first, but always you have a in the first denominator and b in the second denominator. There's a, there's b. So let's take this one and let's find the eccentricity of this problem. Okay, you've got, here's what a squared is. A squared is 48. So what is a? Okay, so if you said the square root of 48, that would be correct. And we don't really need to go any further and solve it any further than that for right now. B squared is 36. So what's b? Yeah, b is square root of 36, which is 6. And a squared plus b squared equals c squared. So a squared was 48, b squared was 36. That equals c squared. So what's c squared equal to? C squared is equal to 84. So what's just c all by itself? the root of 84. If we want to find the eccentricity then of this, we would take the square root of 84, and we're going to divide that by a, which was the square root of 48. And we'll get an answer that is, or you'll get an answer that's approximately, drum roll please, 1.32, which matches up with the rule for eccentricity. It should be greater than 1 for a hyperbola. Okay, here's an easy one. I want you to go ahead and pause, and I want you to try this out and then unpause and see what the answers are. Okay, so go ahead and hit pause now. And here's our answers. This is what you got. 9 is a squared, so a is 3. 16 is b squared, so b is 4. It's basically finding the hypotenuse. So 3 squared and 4 squared is 25. We got the square root of 25 is 5. So the eccentricity is just 5 over 3, which is bigger than 1. And so that one's all fine and dandy as well. For the second part here, we're going to look at the discriminant. So the people that worked with conic sections back in the 1800s, they cooked up this general formula for conic sections where A, B, C, D, E, and F can just change, and that changes what type of conic section that you have. There's certain criteria for determining that just straight out of there. All conic sections could be written in that type of form. Sometimes one of those or two of those or three of those pieces might be 0. That's fine. What really matters for us is what A, B, and C happen to be. That is the coefficient that goes with x squared, the coefficient that goes with xy, and the coefficient that goes with y squared. That's all we need. The discriminant is defined as b squared minus 4ac. You've probably seen that before because when we deal with parabolas and we deal with quadratic equations, that's part of a way that we solve the quadratic formula. We had the square root of b squared minus 4ac. So you need to go ahead and copy down the key concept on page 447. Hit pause. I'll wait for you, I promise. So did you write those rules down? They give us the criteria there for circles, ellipses, parabolas, and hyperbolas. So basically all we got to do is we have to look at an equation. We have to pull out A, B, and C. We plug it into that little formula, b squared minus 4ac, and we see, is it going to be negative? If it's negative, it's either a circle or an ellipse. Then we look at the other criteria to determine which one of them. If it's 0, it's a parabola. If it's the answer we get is greater than 0, we have a hyperbola. So here's the first one. This is comes out of your study notebook, and the other three will be in here too. So here's the first one. We look at this and we say, gee, what's A? And yeah, A is what goes in front of a squared, so A is 2. Yeah, B is what goes in front of xy. You see any of that? No, I don't either. So that means B is 0. And C is the part that goes in front of y squared. So C is 3. So this is all we do. We plug in here what B was. B was 0. And we plug in right here what A was. That was 2. And we plug in what C was. That was 3. So 0 minus 4 times 2 times 3. 8 times 3, that's negative 24. So you see that that one is negative, and that tells us that we're looking at a hyperbola. Hyperbola. Promise. If you went and you changed the form, you'd end up with a hyperbola. Okay. Now, I want you to go ahead and pause and check this out, and I'll give you as much time as you need. You can unpause it. Now, when you're ready, I want you to find out what A, B, and C are. Do the discriminant. Look at what kind of answer you get and determine if it's a circle, a hyperbola, an ellipse, or a parabola. Ready, set, go. And there are our answers. You pick out A, B, and C here. You plug it in. You get a discriminant of negative 64. So that means circle or ellipse. But you see here the A is equal to C. And B equals 0. So that's the criteria for a circle. This one, you get a discriminant of 0. It must be a parabola. And for the last one here, you get a discriminant of 121. Very positive. It's a hyperbola. So you're going to look at your sheet, and you're going to find out which other ones that I want you to do, guided practice. And then one more thing that I'd like you to do, I'd like you to go online and search for, let's see, 3 to 4 applications of hyperbolas. There's a couple in your book already, a couple of pictures, and then if you want, you can go to Wikipedia or something like that and write down 3 to 4 more applications of hyperbolas, and then bring that to class and we'll discuss those things when you get there. Okay, good luck.